Flappy Bird, of course. As you can see here, it has everything the real Flappy Bird has, other than the graphics, of course. It has the bird, the pipes, and the game loop. But somehow, it manages to fit inside of this. Even though you can look at it, it's hard to imagine that this is really a game. So, let's dive in and see how this is actually the most popular mobile game of 2013. First, we have the canvas, where everything is drawn to. It's found here in the code, and there's nothing much to it. It's just an HTML element with a width of 600 pixels, a height of 450 pixels, and an ID of B. The next thing you'll see in the code is the script, where the game code is held. We don't really need to worry about the script tag of this canvas anymore, so we can get rid of them. Now that the extra stuff is cleared up, we can dig into the meat of this thing. There really isn't a good place to start, so we'll just start from the beginning with this y equals j equals 50 expression. If you just started coding, then this might look a little strange, especially since there isn't a declaration and because of the two equal signs. It just happens to be that JavaScript is a weird language, so we'll forget about the func and just focus on the effect. This just sets both the y and j variables to 50, nothing else to it. The y variable represents the y position of the bird, and the j variable is just a shorter way to represent the number 50, as seen here. The next thing to look at is this f equals h equals 99 expression, which, just like the last expression, sets both f and h to 99. The f variable represents the timer that's used to spawn pipes, and the h variable is a shorter way to write the number 100. After this, the next thing to look at would be the v equals 0 expression, which is probably a breath of fresh air in this mess. The v variable represents the velocity of the bird. The last thing that probably looks familiar is this p equals new array expression. This array just holds all of the pipes. After these first four expressions, we have this big c equals b dot blah blah blah. This basically gets a 2D context from the canvas and assigns it to the variable c. The reason I don't have to assign b to anything is because of this fun little JavaScript feature, where you can use the ID of an HTML element as a variable without even initializing it. The next thing we can see here is this fillRect function being bound to the variable r. The reason this is being bound and not directly called is because the function gets called 3 separate times, and writing out c.fillRect adds a lot of characters to the file, so instead we just write r. The next expression to look at is this onClick callback. This makes it so when the mouse clicks on the screen, the bird's velocity is set to negative 15. Now that we're done with the basics, we can get into the game loop. For the game loop, a set interval call is used with an interval of 25 milliseconds. To make this function call smaller, I employed the use of a weird feature of JavaScript, which is that sometimes strings can be evaluated as functions. Without this optimization, it would add about 6 unnecessary bytes to the file, so we keep it like this. This is kind of hard to look at, so let's color everything and remove the extra code. Now, the first thing to look at would be this for loop, but where does it even start and end? Let's point out the key parts of this loop. I've highlighted the condition in red and the body in blue. Both of these things look a little strange, but the condition is by far the strangest of the two. The condition itself uses another feature of JavaScript, which is that this expression will actually return 6, while still running all of the other expressions. So this condition actually runs all of these, while only returning the array p. So in the computer, this entire block of code is equivalent to this. And now that we know how the game loop works, we can really dig in. I'm just going to leave it formatted like this for ease of understanding, but just remember that the code actually looks like this. The first thing that gets run in the game loop is this expression. But why add 0 to something? Well, in the JavaScript Canvas API, changing the width or height of the canvas will completely clear it. So instead of writing this long clear function that adds 6 extra bytes, we just have to write this little expression. The next thing in the code is this r function. This particular draw call is for the bird, and it draws the bird at the x position j, which just represents the number 50, if you can remember, and the y position at the bird y variable. It also makes the bird a j by j square. The next part of the code is the player movement code. It's pretty simple, and it just adds the bird velocity to the bird y. This expression also adds 1 to the velocity, as long as the velocity is less than 8. This is possible because numbers and booleans in JavaScript are actually the same thing. The next expression is a little stranger than the last. It basically increments the timer variable f while also checking if it's a multiple of 100. If the timer is a multiple of 100, then a new pipe is added to the array p. However, as we can see here, there's no if statement. So how does this funky little thing work? Well, this little operation works because these two expressions, which may seem similar, are evaluated completely differently. The first expression will evaluate the first part, see that it's true, and not even consider the second part. However, the second expression will calculate the first part, see that it's false, and then calculate the second part and see if it's true. This means that if the first part of this expression is true, then the second part of the expression will never be evaluated. But when the first part is false, the second expression will be evaluated and a new pipe will be created. But there's another weird thing going on here. The modulo operator returns a number, not a boolean, and there's no boolean expressions anywhere. This, again, works because 0 equals false in JavaScript, and anything other than 0 equals true in JavaScript. So, now that we have a full understanding of all of the code before the for loop, we can actually dig into the loop now. We can remove all of the code before the loop because we won't be talking about it anymore. The condition in the loop is pretty simple. It just iterates through all of the elements in the array P and assigns it to the variable O. This next expression contains the pipe movement code and a quick assignment. This code just moves the pipe 3 pixels to the left and also assigns the pipe x value to the variable n. This expression is probably the simplest thing in the entire code. It just sets the variable m equal to the pipe's y value. After this, we have 2 draw calls that are responsible for drawing the pipe to the screen. And finally, we get to look at this. This single line of code uses so many optimizations that it's barely 20% of its original size. This single line of code is responsible for collision detecting and game resetting. The first part is a simple AABB collision detection, and the second part resets the game if the first part is true. This expression works pretty similarly to the pipe creation expression we looked at earlier. If the first part is false, then it won't even try to evaluate the second part because it's an AND statement. But if the first part is true, meaning there is a collision, then the second part will reset the game, completing the game loop. Now, we can finally understand how this giant mess of code can turn into this, a full Flappy Bird game in only 340 bytes. Thank you all for watching, and I'll probably be coming out with a new video in the next 3 years, so stay tuned.